Welcome to the Lean Blog Podcast. Visit our website at www.leanblog.org. Now, here's your host, Mark Graban.
Hi, this is Mark Graban. Welcome to episode 193 of the podcast for February 5th, 2014. My guest today is Dr. Mark Jaben, and he's going to be talking about our brains and lean and change based on some research he's been doing from his own personal experiences. And in fact, there's a lot of different things he's citing in the podcast. If you go to leanblog.org/193, you can find links to books and articles and the things that Mark is going to talk about here today. He's going to be talking about ideas including our so-called hidden brain, what Mark describes as some of the most troublesome features of our brain's operating system, how the A3 problem-solving process fits well with the way our brains work or should work, and how to deal with so-called resistance to change. So there's a lot to think about. I think a lot of really interesting ideas here. So hope you enjoyed the podcast. As always, you can go to leanpodcast.org or simply leancast.org. We'll save you 3 letters there. That's one Kaizen that I've done recently. But either URL works if you want to find past episodes. And thanks for taking time to listen. Well, Mark, hi. Thanks for being a guest on the podcast and joining us today.
Well, thanks, Mark, and thanks for the opportunity to share.
Yeah, well, sure. So we're going to talk about, I think, some really interesting things today, some research you've done on brain science and connections to lean and change. But before we get into that, can you start off by telling the listeners about your professional background, your medical background, and how you first got introduced to lean?
Sure, Mark. So I'm trained as an emergency physician. I completed a residency in the early 80s, and since that time I've worked as an emergency physician, mostly in small and medium-sized hospitals, and mostly rural areas. For 20 years, I was part of a single group in a pretty high-functioning organization that really was getting better and better over time. But somewhere along the late 90s, things sort of began to change. There were a lot of changes occurring in medicine at that time, and the relationships in the hospital really sort of started to fragment. And by the mid-2000s, the institution was spiraling down, and in 2006, we sort of became collateral damage to that and lost our jobs. And we were left to wonder, how could we devote 20 years of a career to a place and have it come to this? So, because we needed to eat, I started filling in at a few other emergency departments, and what I found out there was that they were struggling with many of the same issues. And I wasn't seeing any of those places doing a particularly effective job at managing those changes. And in fact, a year later, the hospital that I had been at lost its Medicare and Medicaid funding. And it's devastating for the community and something I'm not sure they've recovered from yet. And so, and again, that had been a place that was really delivering quite good care, at one time. So, I thought, there's got to be a better way to do this. And it started me on a journey to find how to better manage change. And in 2008, I had the opportunity to go to New Zealand and work there. And was fortunate enough to land in Taupo Hospital on the North Island in Taupo. To shout out to the folks there, so especially Julie Eilers, who's the administrator, and Kingsley Logan, who was the medical director there. And they essentially, Mark, gave me their institution as a little lean learning lab. I didn't know much about lean at the time, but they were interested in trying this, and I guess I was the outside American, and that seemed to fit. And what I discovered in lean was the first sort of change methodology that, to me, addressed the elephant in the room. What I had seen from my experience is the biggest obstacle to performance in healthcare. So I concluded that there was great value there and opportunity for the U.S. healthcare system. And I think it was during that time, Mark, that you and I first began sharing some emails.
Yep.
And also during that time, I befriended John Shook, who's the CEO of LEI, who kindly took under his wing a floundering doc trying to figure all this lean stuff out, as I'm sure John's done for a lot of people.
Yeah, I've learned a lot from John as well. Yeah.
And at one point, John had asked me what I thought the problem was in healthcare, and my answer was a lack of dialogue. And his response was, well, lack of dialogue is not a problem. Promptly walked off.
Can you say you were jumping into a solution?
Yeah.
We need more dialogue?
It took me a while to understand what he meant, which was that dialogue is a countermeasure, but to what problem? So I kept searching. recently I was able to email John, and I think the subject line of the email read something like, "At last, the root cause." And the root cause, Mark, lies in the way our brain operates. And if you've seen the cartoon which says, "I've seen the enemy and it is us," well, I've seen the problem and it's me, or more accurately, it's my brain.
So tell us, so that's kind of an interesting insight. Okay, so we're even though we talk about not blaming in lean, so okay, we're going to blame our brains. That sounds like a fairly systemic root cause. And so tell us about the research that, or how you started looking into this. Why is this important for the listeners to understand some of these insights about the brain?
Yeah, I think it's, we're all after creativity and innovation. But the fact of the matter is that creativity and innovation are really hard work and hard to achieve. And the biggest impediment that I see to that is really resistance. We all observe that people resist change, or at least people don't mind change, they don't mind being changed.
They don't like being changed.
Yeah. And frankly, we dread dealing with it. And what I've learned in my career in medicine is that when I dread dealing with something, it's generally because I either don't understand it or I don't have an effective approach to it. So when it comes to resistance, the insight to me was that it lies in our brain and its operating system, and specifically 3 troublesome features in our brain's operating system. And I think that if once we understand this, then we can use resistance as the tool that it can be and devise countermeasures that are more effective, making our improvement efforts more effective. So hopefully we'll have enough time today to talk about one that I've been working on. But also, as we work our way through this, I think the listeners will see much that matches their experience with resistance and much that distinguishes the lean approach.
Yeah, so, when we talk about resistance to change, I think sometimes that's a loaded term. Managers will complain that, people are resistant to change, and sometimes that means they won't do what I'm telling them to do. And we don't delve into the reasons why that resistance is there. But tell us a little bit about the brain's response to new ideas, and kind of what some of the sources are of responses that get interpreted as being resistant to change, as if it's a choice, right? There's some of this that's just happening, right?
Right, yeah. So, well, first, I always sort of give a disclaimer when I talk about this stuff because, if you're a neuroscientist or you're married to one, you'll find much to quibble with in what I'm going to say. But so my goal in describing this isn't really to be scientifically pure as much as it is to give us a framework we can use. So the first thing is that whether we're talking about creativity, innovation, improvement, learning, decision-making, all of that is really the same from your brain's perspective. And so we'll need to spend a little bit of time covering some basics on that to understand all this about resistance. So first thing I want to do, Mark, is just give people a mental image that I want you to sort of keep in your mind as we're talking about this, and it's sort of a structure to how this all works. So if you'll do that, start on the left side of your page of your brain and put hidden brain, and then arrow over to the middle to prefrontal cortex, and arrow over to the right for creativity. So the path to creativity is pretty well specified, and it can't be short-circuited, and you can't skip steps and expect to get there. So the hidden brain is where the existing neural connections reside. The prefrontal cortex is where these connections are analyzed when you need to do that. And creativity, the definition I like, is the connection of previously unconnected thoughts. So the brain doesn't jump straight to making these new connections because, well, it takes a lot of energy to do that. And our brain is very much geared to not knowing if the next meal is coming. So it has devised a system that requires the least caloric intake possible. So the good news is, that we are rational creatures. We are capable of gathering data, analyzing, and acting upon it. It's just that's not the way we make most of our decisions most of the time. And this occurs in what some researchers call the hidden brain. So the hidden brain does this based on these existing neural connections, patterns of recognition and response, which have been developed over millions of years in experience, standards, if you will, that are constantly being monitored and upgraded. And it takes in the data from our senses, and if it recognizes a pattern, then it can respond. It doesn't take much energy to do that. The thing about the hidden brain is we don't know what goes on in there. We aren't aware of it. We have no direct link to it. So the only way we know about these decisions is through our feelings and emotions. It's a very rapid communication system. And this works really well, except when we face a new or novel situation where there's no pre-existing pattern. That then becomes the role of prefrontal cortex, which is to fact-check the hidden brain and to be vigilant for these outlier circumstances. So your prefrontal cortex can focus very intensely on an issue and bring vast powers of analysis to it. But the problem with the prefrontal cortex is that it's easily overwhelmed. And researchers believe it can only handle sort of 4 to 9 variables at a time, which is why multitasking is a myth. You know, our brain really can only do one thing at a time. So if the prefrontal cortex evaluates the existing connections and doesn't get a satisfactory response, then and only then is the brain willing to expend the energy necessary to make these new connections. And that's the aha moment we get when we put things together in a new or different way that works. And when things work, it feels good and right, and it feels that way because we get a release of the chemical dopamine whenever we do something, you know, that our brain approves of. So, namely, something it believes will enhance our chance for survival.
Yeah.
Right? So, Mark, this leads actually to the first troublesome feature of your brain, which is this. The brain is not into reality, it's into plausibility. And what I mean by that is it's into making a plausible explanation of the data it receives. And why is that? Because our brain is geared to action, which is to fend off the immediate threat in front of it. And if you think about it, that kind of makes sense. Because if we spend too much time, you know, analyzing the speed of the saber-toothed tiger, you know, what direction it's coming from, how big its jaws are, you know, do I fight, which way do I run? Well, we spend all that time, it doesn't really matter anymore.
Right.
So our brain, and even more importantly, the brain will take this plausible explanation and treat it like a fact, even to the point of discounting clearly conflicting data so that it can maintain that story.
So this is kind of evolutionary. This is the fight or flight response that gets in the way of that higher order thinking, right?
Right.
Yeah. I mean, back in podcast 153, I talked with Robert Moore from UCLA, who's a psychologist and has looked at Kaizen, and that's one of the things he really focuses on is the idea of, you know, what our brains are doing to us, and you know, instead of telling people don't be scared of change, to recognize that, well, it's a very natural human behavior to be scared by change, and
right.
to be aware of that, and then try to figure out how to get through that. You know, his strategy is classic Kaizen is, well, you know, make the change small. Instead of a saber-toothed tiger coming at you, it's just, you know, make the change small, and it's just a leaf blowing at you. It doesn't scare you, and then you can think creatively. But
right.
That's kind of same idea. What you're talking about is that our hidden brain, the amygdala, will take over or get in the way, right?
Right. That's right, Mark. And it actually becomes a little scarier than that because, you know, we also can't really depend on our memories. You know, all our memories are not really imprinted, or there's some recent data to suggest that memories imprinted, we just can't retrieve them all. So what we do is we remember the stuff that most impacts our chance for survival. So we have memories that are selected, and then it's been shown that no matter how well memory is imprinted, it can change over time. So the really scary part of this, as you say, is that you can't depend on your brain for an accurate appraisal of the current condition. Mm-hmm. So when you get feelings that are really certain about something, you should be really afraid because you're likely missing something. Mm. And if you feel uncertain about something, well, you need more data. So the question is, where will that come from? So that leads us to the second troublesome feature of your brain, which is the hidden brain is actually made up of many separate functions, and each one of those functions has a particular area of interest. And it focuses on that area of interest to the exclusion of the others, and will eagerly tell you what you should do from its perspective. So when you get a feeling, you know, it's not an arbitrated, mediated, negotiated settlement. It's the loudest voice that wins. Because remember, your brain is geared to act quickly in the face of danger. So those other perspectives are in there. They're just being drowned out. And as you said, Mark, talking about the amygdala, that's your flight or fight stress response area. And your amygdala is one of these very prominent hidden brain voices, and it's focused solely on your individual survival. So there have been very nice functional MRI studies that show that when somebody's expressing a closely held belief, what lights up is their amygdala. But when the same person is considering options and alternatives and other perspectives, now they're processing their prefrontal cortex. So what this means is forget having a fruitful discussion with someone who's in their amygdala. They're just not capable of it, and the same is true for you. So the second troublesome feature is this, which is our default response to anything is from our amygdala. So when we begin to interpret the world, we always start there in the amygdala, which is our personal survival. So our personal survival trumps everything else.
Mm-hmm. So on these 2 points, how would you tie it back to the workplace, an emergency department or a hospital? I think some of the things people are fearful of, like people are fearful of losing their jobs. Can you think of some scenarios where you might recognize when people's amygdalas, their hidden brain is taking over? How do you recognize that? What can you do about that?
Yeah, it can be really hard because people who are on the face of things resisting something, who are saying no to whatever you're suggesting, they're not necessarily in their amygdala. You could have people saying no to something who are analyzing very carefully and have
Right.
very important dissenting views, and they're in their prefrontal cortex. They're considering options and alternatives, and they're seen in a certain way. And on the other hand, you can have people that are saying, yes, I'll do it, and then don't follow through. And they appear to be in their prefrontal cortex, but actually they're in their amygdala, and they've just figured out that the best way to protect themselves is to play along as far as they're willing to play along. So it's not easy at all. And this leads actually, Mark, to what the third troublesome feature is in terms of how we deal with that. Because somewhere along the line in evolution, people discovered that at times being part of a community would improve their likelihood of personal survival. So, for instance, it was, I'm not big and strong enough to kill the bison myself, so I might starve. But together we can kill the bison, so we all can eat. And so the brain actually evolved an adaptation for this, because if you're going to live and work with others, it requires that you be able to acknowledge and accommodate the needs of others. So this is your mirror neurons. And mirror neurons enable us to, for instance, see a picture of a person in pain and be able to feel that pain without having to directly feel it ourselves. So that's really great. That's helping us entertain some of these other perspectives that our plausible explanations want to ignore. Because if you remember from a little bit earlier, your brain will ignore clearly conflicting data in order to keep its story intact. But there's a problem here, because researchers have demonstrated that the more power and control a person has in a given circumstance, the less active are their mirror neurons. So what do we do when we put people in leadership positions and we expect them to be aware of all that's going on? They're less capable, less inclined, less able even to do that. And from an evolutionary sense, that makes some sense to me, because a leader might be called on to make really sensitive decisions, time-sensitive decisions that favor the survival of the group, but maybe at the expense of certain individuals. And if they're so concerned with those individuals, they may not be able to act on the benefit of the group. So this effect on mirror neurons makes some sense to me. But when it comes to a complex world that we live in, where we have many people involved in anything and many options to respond and conflicting priorities, the best decision in any circumstance involves challenging that plausible explanation and accommodating the needs of others. So this effect of mirror neurons doesn't serve us well in that environment. Mm-hmm. And in our world, we have more power control in our lives than at any other time in the history of man. So it's not a matter of who we are. It's any of us would be equally subject to that effect.
Right. Yeah, and that's, like I said, that's what our brains are doing to us. I think back to workplace scenarios. People move up the ranks through an organization, and maybe they get disconnected from the workplace. They lose, for a lot of different reasons, the ability to be empathetic to what employees are facing. Some of that could be, as we would say in Lean, well, they're not going to the Gemba, they're not seeing firsthand. But it sounds like you're saying, maybe you can elaborate on this. Some of this is what's happening to their brains because they have because they're in a position of increased formal authority and power.
Sure. I think I've seen it in my physician colleagues who went from the bedside to the boardroom. Well-intentioned, good-meaning people who understand what the practice of medicine is, but again, the farther away you get from the bedside, the harder it is to recall exactly what goes on there. So, yeah, and I think empathy is interesting, Mark. That gets a lot of talk these days. But I think what I'm talking about is even beyond. It's more than just empathy, because empathy sort of carries the connotation that's kind of optional. I can be empathetic or not. I can look at this other situation and not. But what I'm really saying is that this effect of the mirror neurons is not optional. If you want to be able to get to creativity, if you want to be able to get to innovation, it follows the path through the prefrontal cortex. And if you never get to processing the prefrontal cortex, you'll never get to creativity. So, I think you did a recent podcast with Karen Martin, and she mentioned at the end of that sort of her interest in exploring the role of hope when it comes to improvement. So if you go back to that diagram that I posited early on, the hidden brain arrowed to prefrontal cortex, arrowed to creativity, what is hope? Hope is seeing a path, having a plan to move forward. Your brain really likes the idea that presents a better chance for survival and will respond, with a dopamine squirt. That's why hope is so important. And, I think in a subsequent podcast with Rich Sheridan from Menlo Innovation, he spoke about creating a joyful workplace. That was the whole intent of their effort. And, joy comes when you're able to act on that plan. And, your brain really, really applauds that. So, you talked before about what are some of the other scenarios where it happens. So what do we do in our workplaces? We apply lean tools and PDCA, Kaizen and Kaizen events and Hoshin Kanri. And these are all structures that help us clarify a path forward. But this is prefrontal cortex processing. And remember what happens if the other person is in their amygdala. They're not capable of having that sort of participation that prefrontal cortex thinking requires. And so what do? Just as you said, we want to hold somebody accountable, which, as you said, usually means why aren't you doing it the way I want you to do it? Or we want buy-in. If somebody's buying something valuable, do you really have to convince them that they need to buy that? So, and what do these do? Well, these are perceived as threats. And what do threats do? They just force the person deeper into the amygdala. So, if you never get past the amygdala, you can't get to prefrontal cortex thinking, and you'll never get to creativity and innovation. So that's why, recognizing, responding, and reconciling resistance is so crucial. It's what I call the 3 R's of resistance. So the root cause of resistance is not rational. It lies in the hidden brain, and it doesn't respond well to a rational approach.
So so you talked about the different troublesome features, as you called them, the hidden brain, the separate functions. Are there any others that you've seen?
No, those are really the main three. And, you had mentioned, in the past you've always talked about Dr. Deming speaking of the need to stamp out fear. And I think that's what he's really talking about in this regard. You have to stamp out the fear to be able to get to the prefrontal cortex. And I think also this is why respect for people principle is so integral.
Right.
Bob Emiliani's talked a lot about that. Bob's been really helpful to me in sort of working out these concepts thanks to Bob. But, I kind of believe the ultimate form of respect really lies in how I deal with resistance. Do you remember some years ago you and I were at a conference with Dan Florzone?
Yeah.
And I think you've had Dan as a podcast
He
guest.
was a very recent guest, yes.
Yes. And he said something to us that was really took me a long time to come to grips with. And what he said was, if he wasn't getting pushback or resistance as a leader, he wasn't doing his job. Remember him saying that? So, I thought a long time about that. And what I think I understand now is, remember, we don't have a direct connection to what's going on in our hidden brain. But I think I would restate this for Dan and say now that resistance is the one tool we have to where we can gain some insight into the hidden brain. And, the hidden brain, I think, is where the point of cause is, if you will, for what gets in the way of our improvement efforts. So, if we want to move forward, we better embrace it. So that requires a tool, I think. So the tool, I think, is this. There's a scale. That scale has resistance at one end and satisfaction at the other end. And what you need to know is where the person lies on that scale. So that speaks actually to another problem we have, which is what satisfaction is. And I think we've horribly misinterpreted what satisfaction means. So we believe, I think, conventionally, that it's about what the other person wants. But what I want is really amygdala thinking. Satisfaction is really about what people need, and that's a prefrontal cortex process. And when that person is satisfied, we know they're in their prefrontal cortex. So what's an example of this? So you take a patient who's newly diagnosed with cancer, right? That's a devastating bit of information to get. The person's depressed. What are they going to do? They're already putting nails in the coffin. What happens the next week? They go to see their oncologist. They get staged. They get a treatment plan. And now what's their attitude? Well, they're going to fight it. They have a path forward. They have hope. If you ask a person, is satisfaction dependent on what somebody wanted, then they would never be happy with their oncologist because nobody wants to have cancer.
Right.
But if you ask them, once they have this path forward, are they satisfied? They'll say they are because, again, they're getting what they need in that situation. Mm-hmm. So to me, what Dan was talking about is this. And unless we take on this resistance, actively seek it out, embrace it, work on it, we can't ever get where we want to go in terms of satisfactory responses to our situations.
Yeah.
And Mark, that talks also about why the A3 process works. If you think about it, the A3 process, you got to complete the left side before you go to the right. So the left side is all about getting from your amygdala to your prefrontal cortex, to getting what I think is wrong, gathering other perspectives, validating the current condition, onto analysis and root cause identification. That's prefrontal cortex thinking. The right side is, of course, all PDCA and reflection, in which we either decide that the countermeasure works and we're going to stay with it, or if nothing works, we're opening up the possibility that maybe we need a new and novel response, which is creativity. Yeah. So if we go there prematurely to the right side, people just aren't ready for it.
Yeah, I think it's interesting. You talk about that shift of what we want, that survival instinct. I want food. I want safety, as opposed to saying what I need, requiring more creative thinking. I think it's an interesting thought. You mentioned, I just want to mention for the listeners, past episodes, if they haven't heard them, you mentioned Dan Florazone. He was episode 180. So you can go to leanblog.org/180. And then you mentioned earlier the myth of multitasking. I actually got to interview Dave Crenshaw, who's the author of a book called The Myth of Multitasking, episode 100. So that's leanblog.org/100. So thank you for kind of tying together, some of those themes from past episodes that are all out there on the website. So I'm curious to a little bit more. Summarize what you're saying is that the A3 process helps us is because of the structure. It helps us get from kind of reactive, short-term, hidden brain and into the deeper thinking parts of the brain.
Well, I think that if you think about lean as something that has evolved over many years by many people, keenly observing the way people work and interact and how they work together, and then through millions of PDCA loops, essentially revealed a system that actually reflects the way our brain works. Mm-hmm. Now, they didn't have access to all this research and functional MRIs and stuff, so there was no way for them to know that this was going on. But it's interesting to me that the product of what came out of lean really is that direct reflection to our brain, and I think that's why lean works so well. Mm-hmm. To me, Mark, the benefit of lean is that it is a system to deal with resistance. Yes, we want to elucidate problems, we want to solve problems, but in order to do that, we've got to get past this resistance. And lean, what attracted me to lean in the beginning was that here, built into the methodology, is a mechanism to do that. It wasn't an add-on, it wasn't an extra, it wasn't optional. It was part of what you do to do lean effectively. Yeah. So, the countermeasure that I propose is even a greater focus on this left side of the A3. I'm calling it the engagement kata because it's a routine that sometimes we're going to need to gain the participation that we need to do the testing and trialing phase, the right side of the A3. So I don't know if we have a couple of minutes we can delve into that, or
let's not tease people with that for a future podcast. So you're saying the engagement kata. Well, first off, for people who might not know, they might know Mike Rother and Toyota kata, but what do you mean by first off by kata, and then what an engagement kata is?
So a kata is a routine. So, I mentioned before, my experience in medicine is when I struggle with something, it's because, I either don't understand it or I don't have an approach to it. So if we have an approach, what we've created with an approach is a structure to help guide us forward. That's what hope is, the path forward. So a kata is a routine. It really comes out of the martial arts regimen. And, when you start to do, I've never done martial arts, but what I understand is when you start to do martial arts, the first step is you follow the form and you learn the form exactly as instructed. So again, a kata is just a routine to help you recognize that resistance in this case is there, and then how am I going to respond? What am I going to do? What are the steps I'm going to take that will work me through that, get me from amygdala to prefrontal cortex?
So Mark, as you continue researching this, I'm going to put you on the spot and push you to maybe write about this, or I don't know if you want to start a blog or a group. I mean, if people want to discuss this with you, I guess for one they can come to the blog page for this episode. If you go to we announced that at the top of the show, leave a comment. Are there other ways that you imagine, like, do you want people collaborating with you on this, or if they want to discuss this?
Sure.
What are some different ways they might be able to do that?
Yeah, no, I love talking about this stuff with folks. I guess the best way, Mark, is through my email, which is Jaben, MM, so that's JABENMM at AOL.com. And I think also, Mark, we can post attached to the podcast a list of the references that I've sort of used, the resources that have been helpful to me. And I guess I can also include some brief summaries of some of the particular studies that have been so impactful to help me understand this.
Mm-hmm. Well, good. Yeah. So you sent me those. I will post them on the page for this episode, and people can check that out. They can post comments. If there's some good discussion in the comments thread, we can maybe get together and do this at some point down the road when we've got some new insights or some other examples or other questions to share. So. Really appreciate you talking about this, Mark. I think it's really interesting topic. We talk about root causes. I mean, I guess going into the depths of our human nature, I guess, is important. You mentioned earlier the respect for people principle. I think it's interesting that Toyota's original term for this was the respect for humanity system, and I think part of that doesn't mean just treat people respectfully, but respect what makes us human in terms of, don't expect people to never forget things, don't expect people to be superhuman, and it seems like this is a big part of it, respecting the way our brains work, and that is what it is. I guess we can cope and better understand that leads us to hopefully better lean implementation. So on that, I'm curious if you have any final thoughts you'd want to wrap up on.
Yeah, I think again, to me, the ultimate form of respect is how I deal with your resistance, because it acknowledges that you have a valid view, and it requires me to rethink my view. And I think that's the most important thing about resistance. I reflect back to Dan Florzone's comments. If we aren't actively embracing resistance, then we're missing the best opportunity we have for the kind of creativity and innovation we need. Healthcare is really complex, and there are a lot of stakeholders. Each has their own plausible worldview, and they each speak really different languages. When John Shook asked me what the problem was in healthcare, I answered a lack of dialogue, a countermeasure, but to what problem? And I believe that problem really is a lack of credibility among those stakeholders, and the root cause of that really lies in this suppressed mirror neuron activity. So if we want to be more successful at shepherding change in our organizations, well, I think we'd be well served by focusing there.
Well, great. Well, again, our guest has been Dr. Mark Jaben, not to be confused with the non-Dr. Mark Graban. We have such similar sounding names, Mark Jaben and Mark Graban. There's a fun story there that we'll maybe have to save for another time. But thank you so much for sharing some of your thoughts and insights and research, and for being a guest here today.
Well, Mark, thanks. I can't express how valuable you've been to my career, or at least our names. And Mark, I'm really honored to now be part of the long list of distinguished guests you've had on the podcast, and hope that the listeners find this valuable.
Yeah. Well, thank you. I'm sure they do. I hope they do. So.
Hello again. Gaze into a mirror and what do you see? Well, I see my face, of course, but in my face I see moods, I see shifts of feeling. We humans are really good at reading faces and bodies because if I can look at you and feel what you're feeling, I can learn from you, connect to you, I can love you. Empathy is one of our finer traits, and when it happens so easily, perhaps because, and this is brand new science, this is just out of the lab, we may have some special circuitry in our brains that helps us whenever we look at each other. Ask yourself, why do people get so involved, so deeply, deeply involved with such anguish, such pain, such nail-biting tension over football?
Cleveland Browns are gambling on defense.
Why are we such suckers for sports? And it's not just sports. We can lose it completely at the movies, at video games, watching a dance. Is there something about humans particularly, that allows us to connect so deeply when we watch other people? Watch them moving, watch them playing, watch their faces. Well, as it happens, scientists have an explanation for this strange ability to connect. It's new.
It had never been found on the cellular level before.
A set of brain cells found on either side of the head. Among all the billions of long branching cells in our brain, these so-called mirror neurons have surprising power.
What we found is the mechanism that underlies something which is absolutely fundamental to the way that we see other people in the world.
And it began entirely by accident at a laboratory in the lovely old city of Parma, Italy, where a group of brain researchers was working with monkeys. And they were testing a neuron, that's a brain cell, that always fired, made this sound, whenever the monkey would grab for a peanut. So the lab had all these peanuts around, and whenever the monkey made its move, the neuron would fire. Scientists thought, now here's a neuron that is essential to motion. It's a motor neuron. Then one day the monkey was just sitting around, not moving at all, just sitting, when a human scientist came into the lab. And when that scientist grasped the peanut, the monkey's cell fired. Now, the monkey hadn't moved. It was the human that had moved, suggesting that this neuron up here couldn't tell the difference between seeing something and doing something. Seeing and doing were the same. Or more intriguingly, that for this neuron, watching somebody do something is just like doing it yourself. The head of the lab, Giacomo Rizzolatti, thought, wow.
The same neurons, one neuron, fire both when the monkey observes something and when monkey is doing something. It's almost unbelievable.
It was surprising because this cell which was involved with motor planning for the monkey turned out to be interested in the movements of other people as well.
Some people call them monkey see, monkey do neurons, but the name that stuck is mirror neurons, because with them, the brain seems to mirror the movements it sees. This accidental discovery got scientists thinking, doing more tests, and it soon came pretty clear that this is not just a monkey thing. It's a people thing, too. We all know that humans learn by looking and copying. That's what infants do. First you look, then you do.
Ready? Let's see your feet this way.
And once you've watched and copied and learned a set of moves, you not only have them in your head.
Look, you put your shoe on. Yeah, she brushed it.
If you see somebody else doing it, you can share the experience.
And you want to do it with me?
They know the moves, you know the moves, so you can move with them.
Wow.
If you can use the years of training that you yourself have done, learning to crawl, then learning to walk, then learning to eat, this is an incredibly rich set of knowledge that you could apply to the problem of actually seeing what's going on.
So that's why when I head down this street carrying all of these packages, not only do people watch, look how they're watching. They feel my predicament, because they know what it's like to carry heavy packages. They all know about carrying. So as they watch me moving, they can feel themselves moving. their neurons are mirroring the action. These neurons may be the brain's way of translating what we see so we can relate to the world.
The mirror system is the way that you tap into, the way that you harness your own abilities and project them out into the world.
And people are really good at watching and translating what we see. Like with just 13 moving dots, that's all there are here, you'll have no trouble recognizing these very ordinary activities. What's more, tests have shown when a person sees a movie like this of his own movement, he'll recognize it immediately as his own. And that's why sports fans tense with the action and wince and leap, because if you know the game, then your neurons are firing as if it's you playing, giving a whole new meaning to the phrase armchair quarterback. That's why it's so easy to be a sports fan. But there is more, suggests UCLA professor Marco Jacoboni. He thinks mirror neurons tie us not just to other people's actions, but to other people's feelings.
So the idea was to try to figure out how the emotional system and this motor system are connected together. We're going to go in the scanner. What you're going to do is
to demonstrate, he put me into this very powerful fMRI brain scanner that can peer into the brain while it's working. And he gave me some goggles so he could show me pictures when I was in there.
So you can see here the eyeball of Robert.
And once he had a good view into my brain...
Nice looking brain.
Thank you.
Robert, you're not supposed to talk when we scan you, all right?
Sorry. Then he said, okay, I'm going to show you a bunch of faces. And for each face, I want you to imitate it. So I did that. Then he recorded my brain while I moved my facial muscles.
We're going to do right away another one.
Okay. Then he said, okay, same faces, but this time, don't move a muscle. Just look. So I looked. When we checked the results...
Oh, there's my brain. I've never seen my brain before.
This is your mirror area.
Jacoboni says that the part of my brain that's working when I make a face, the same part gets busy when I see the face. Plus, when I was looking at these faces, I remember feeling extra uncomfortable, kind of bad. But when these faces came on, I felt better, almost happy. And in fact, at the moment I was looking at the happy face, my brain, and this is my brain, in that instant, see the red area here? It shows activity in the happy emotional part of my brain. And when I was imitating happy faces, look, I get even a bigger response. This, says Jacoboni, is a consistent result. Mirror neurons, he believes, can send messages to the limbic or emotional system in our brains. So it's possible these neurons help us tune in to each other's feelings. That's empathy.
We strongly believe that that's a unifying mechanism that allows people to actually connect at a very simple level.
You're saying that there's a place in my brain whose job it is to live in other people's minds, live in other people's bodies.
That's right.
Oh, darling, I'm going to die. Don't let me die.
Yeah.
And great actors instinctively know that if they put feeling and drama into their bodies,
Hold me tight. Don't let me go.
their faces,
It's dark out there alone.
we will respond.
Can't die. You're too brave to die.
What actors are expert in is using their movements to inspire feelings in the people watching. These are the experts in the mirror system.
We are intensely social creatures. We literally read other people's minds. I don't mean anything psychic like telepathy, but you can adopt another person's point of view.
When you put it together, what do you think it's going to be?
So if mirror neurons help us connect emotionally, what about people who have trouble with this? Kids like Christian, who has autism.
Why do you like Legos?
It's been known for some time that children with autism could be quite intelligent, but have a profound deficit in social interaction.
There he is.
Christian can speak and read and write, but like many kids with autism, he will avoid eye contact. He often misunderstands questions.
So, Christian, can you tell me what you did in school today?
Doing well.
You're doing well?
Everybody wants to know what exactly causes this. So Dr. Ramachandran and his graduate student, Lindsay Schenk, designed an experiment.
So we're going to be reading your brainwaves with this cap.
They recorded brainwaves while the kids opened and closed their hands, and while they looked at a movie of somebody else's hands. For most people, the brainwaves look the same either way, whether they're doing or seeing. But for kids with autism, the wave changes, suggesting possibly that autism may have something to do with broken mirror neurons.
Their brains may indeed be different in that regard, and they may have deficits in the mirror neuron system. But we don't know this for sure yet, and additional work needs to be done using brain imaging.
But what we do know, says Ramachandran, is that healthy human beings are intensely social. More than our cousins the monkeys, we invent ways to connect. We invent dances and handshakes and games to play. We eat together, we meet, and we talk. We talk a lot.
Get away. Everybody's interested in this question. What makes humans unique? What makes us different from the great apes, for example? You can say humor, you're the laughing biped. Language, certainly. Okay? But another thing is culture. And a lot of culture comes from imitation, watching your teachers do something.
And here V.S. Ramachandran makes a big leap. He has proposed that at a key moment in our evolution, this is his guess, our mirror neurons got better. And that made all the difference, he says, because once we humans got better at learning from each other, looking, copying, teaching, we could do things the other creatures couldn't.
In other words, if you are a bear and suddenly the environment turns cold, you need a few million years to develop a polar bear type layers of fat and fur.
It would take many, many, many bear generations to select for furrier bears. But, says Ramachandran,
if you're a human, you watch your father slaying another bear and putting on a fur coat, skinning it, using that as a coat. You watch it, you learn it instantly. Your mirror neurons start firing away in your brain. And you perform the same sequence, complicated sequence. Instead of going through millions of years of evolution, you've done it in one generation.
And while no one's claiming that mirror neurons are the key ingredient that makes us different from other creatures, what these neurons do suggest about us seems almost self-evident. You can see it any Sunday at a sports bar. That deep in our architecture, down in our cells, we are built to be together.
There would be very little point in having a mirror system if you lived on your own. There'd be a lot of point in having a digestive system if you lived on your own. There'd be a good point in having a movement system if you lived on your own. There'd be a good point in having a visual system if you lived on your own. But there'd be no point in having a mirror system. The mirror system is the most basic social brain system. It's a brain system which there's no point in having if you don't want to interact or relate to other people.
But we do like to interact, and maybe now, as never before, we will understand why.